Hello everyone, I am Brandon Ordoñez from ECE41 and today I will be performing our experiment number 3 for our Internet of Things laboratory, which is entitled Blinking LEDs and Push Button Application in Raspberry Pi 4 using Python. Hello everyone, so now let us begin with our experiment. So for experiment 3 of our Internet of Things laboratory, the first challenge is port Spark Fun Starters Kit Circuit 1 Blinking LED into Packet Tracer 7.1 using the PT MCU as the microcontroller. Tips: you will have to port the code presented on SIK to Python. You will also have to modify the pins used on SIK to adapt PT MCU's pin numbering system. And since we will not use Packet Tracer, we will use our Raspberry Pi 4 for this experiment. So the alternative challenge is create a Python code that will create a blinking LED using Raspberry Pi 4. There. So this would be the code. Hello, so now we would be opening our part 1 file, which is created using Tony Python app in our Raspberry Pi. So first, for the code, from GPIO0 import LED, from time import sleep. So these two are used to input configurations for our code. Next, we set variable light for the LED, and the main loop occurs while true. So while there is power, light will turn on, and which is for 0.5 seconds, and turn off for 0.5 seconds. So this will result for the LED to blink. So from the code, we see that we have used 27 beside the LED. So this means that we would be utilizing GPIO 27 in our Raspberry Pi pin configuration. So after preparing the code, this is the circuit assembly of our first part of our experiment. So first, the LED is connected to GPIO 27 as seen from our code that is presented earlier. Next, the other side of the LED is connected to the resistor, which is connected to the ground, while the ground terminal of our breadboard is connected to the ground port in our Raspberry Pi 4. Hi, so this is the circuit for the first part of our experiment. So now let us click run. So it is expected that the LED will blink every 0.5 seconds. There. As we can see, the LED is blinking for an interval of 0.5 seconds. So for the second challenge of our experiment, or the second part, using the concepts presented on SparkFun Starters Kit Circuit 1 blinking an LED, Circuit 4 multiple LEDs, and Circuit 5 push button, use Packet Tracer 7.1 or newer to create a circuit that illuminates one of the 8 LEDs in sequence every time the push button is pressed. So requirements: you must use 8 LEDs and they must be lined up. Every time the push button is pressed, the current LED goes dark and the next one illuminates. There must be only one LED lit up at any given time. So for the tip, use the PT MCU as your microcontroller. So for here, we will use again our Raspberry Pi 4 and we will program using Python. So this is the code for the second part of our experiment. So the first thing that we did is we have designated which pins would be used as input and output for our circuit. So first, we could see that pin 2 is used for our input. So pin 2 would be where the push button is connected. So for the first LED, which is our output, it is at pin 17. Next, pin 27, 22, 23, 24, 25, 5, and 6. So next, for the main loop of our circuit, while true, so while there is power, so a message would appear saying that we need to press the button. So else, while the button is being pressed, summing would occur. So every time that you press a button, the value of count would increase. So first, upon pressing the button once, so pin 17 would light up, which is our first LED. Upon pressing the button twice, pin 17 would turn off, while pin 27 would turn on, which is our second LED. Next, while the button is pressed thrice, pin 27 is off, and pin 22 is on. Next, while the button is pressed 4 times, pin 22 would be off, and pin 23 would be on. Next, while the button is pressed 5 times, pin 23 would be off and pin 24 would be on. If the button is pressed 6 times, pin 24 would be off and pin 25 would be on. So this pattern continues until we have reached pin 5 and pin 6. So if we press the button 7 times, pin 25 would be off and pin 5 would be on. If we press the button 8 times, pin 5 would be off and pin 6 would turn on. So this is the last part of our code, which is just a clean up code. So this is the way to end our code for part 2 of our experiment. So this would be our circuit assembly for part 2 of our experiment. So we have lined up 8 different colored LEDs and 8 220 ohms resistor. They are all connected to the ground, with reference to the ground. Also, we have placed our push button, which is connected to the ground too. So first, the first LED is connected to GPIO 17. Next, the second LED is connected to GPIO 27. The third LED is connected to GPIO 22. While the fourth LED is connected to GPIO 23. The fifth LED is connected to GPIO 24. The sixth LED is connected to GPIO 25. The seventh LED is connected to GPIO 5. And the eighth and last LED is connected to GPIO 6. So the push button, the positive side of the push button, is connected to GPIO 2. And afterwards, the ground is connected to the ground terminal of our breadboard. So we could observe that we use the pins here with reference to the program that I have shown earlier. So now let us show the results of this experiment. Hi, so now I have finished building the circuit for the second part of our experiment. So it is expected that every time I press the button, the next LED would light up, while the previous LED would turn its light off. So now let us try. There, as we can see, LED 2 lights up while LED 1 turns off. Next, there we can see that LED 3 lights up and LED 2 lights off. Next, we could see that LED 4 lights up while LED 3 turns off. So the same happens, LED 5 lights up while LED 4 turns off. Next, LED 6 lights up while LED 5 turns off. LED 7 lights up while LED 6 turns off. And lastly, LED 8 turns on while LED 7 turns off. So if I press the button again, it is expected that LED 8 would turn off while LED 1 would turn on. So let us try. There. So that is it for our experiment number 3 for Internet of Things Laboratory. So I hope you learned something, and thank you.